If you open up almost any electronic device, whether it's an old radio, a game console, a TV, or a modern laptop, you'll probably notice the same thing inside: a green circuit board. Most people see it so often that they never stop to ask why it's green in the first place. But the truth is, circuit boards are not naturally green at all. Under that familiar green surface, the board is usually more like brown, yellow, or tan, almost like wood or hardened paper. So why did the electronics world choose green as the standard color? The answer is actually a mix of science, history, and practicality. To understand it, first we need to know what a circuit board really is. A PCB, or printed circuit board, is basically the backbone of most electronic devices. It holds all the tiny parts together and allows electricity to flow between them. You can think of it like a roadmap for power inside your device. The board starts as a hard base material made from layers of resin and fiber, and then a very thin sheet of copper is added on top. Manufacturers remove the unwanted copper so that only the needed pathways remain, and these pathways are called traces. In the early days of electronics, that was pretty much all there was: a plain board with exposed copper lines. But that created some major problems. Copper is useful because it carries electricity well, but it's also fragile. It can react with air, wear down over time, and become damaged during production. There was also a huge issue during soldering, which is the process of attaching electronic parts to the board using melted metal. Tiny bits of solder could accidentally spread between two copper lines and create a short circuit, which could ruin the entire board. As electronics became smaller and more advanced, manufacturers needed a way to protect the copper and control the soldering process better. That's when the top colored layer was introduced. This layer is called a solder mask, and it covers most of the board except for the tiny spots where components need to be connected. The solder mask helps protect the copper from moisture, dirt, scratches, and corrosion, and it also keeps solder from spreading where it shouldn't. In other words, it's not just there to make the board look nice. It actually plays an important role in how the board functions. And technically, this protective layer can be made in many different colors. You can find circuit boards in red, blue, black, white, and even purple. But green became the most popular by far, and one of the biggest reasons has to do with human eyesight. Before machines and automated scanners became common, circuit boards had to be inspected by real people. Workers would spend hours staring at tiny details under bright lights and magnifying glasses, looking for broken traces, scratches, missing connections, or manufacturing defects. That kind of work puts a lot of stress on the eyes, so manufacturers wanted a color that would make inspection easier and less tiring. Green turned out to be one of the best choices because human eyes are especially good at detecting green. We can notice subtle differences in green shades more easily than many other colors, which makes it easier to spot small defects and fine details on a board. Brown didn't provide enough contrast. Red could look messy. Blue was often too dark, and black made details harder to see. But green hit the perfect middle ground. It offered strong contrast without being too harsh on the eyes, which made it ideal for long hours of visual inspection. But human biology is only part of the story. Another major reason green became standard was the military. During the mid-20th century, the US military was one of the largest buyers of advanced electronic equipment, and when the military preferred a certain standard, manufacturers usually followed. Green became widely accepted in technical and industrial environments because it worked well for readability, inspection, and consistency. Once electronics companies were already producing green boards for military-related equipment, it became easier and more cost-effective to keep using the same materials and processes for civilian products too. Over time, green stopped being just one good option and became the default choice across the entire industry. Then there's another important reason green stayed on top. It kept getting better simply because it was used the most. Since green solder mask was already the most common, manufacturers and chemical engineers spent more time improving it than any other color. That meant better formulas, more testing, better consistency, and more precise results during production. So green didn't just stay popular because of tradition. It also became one of the most refined and reliable options available. In many cases, It simply worked better in large-scale manufacturing. And today, the reason green is still everywhere is mostly because of industry inertia. Once a factory has been using the same material, process, and production setup for years, changing to another color can cost time, money, and extra cleanup. Manufacturers would need to switch materials, clean equipment, adjust quality checks, and potentially deal with waste, all for something most customers will never even see. After all, circuit boards are usually hidden inside plastic or metal cases, so from a business point of view, changing the color often just isn't worth it. So in the end, circuit boards are green not because someone randomly thought it looked cool, but because green turned out to be one of the most practical choices for manufacturing, inspection, reliability, and standardization. It's a great example of how engineering decisions are often shaped by a mix of biology, history, economics, and habit. And sometimes, when something works really well, the world just keeps using it for decades. So the next time you open up a piece of technology and see that familiar green board inside, you'll know that color is there for a reason. And it has a much more interesting story than most people realize.